What is a subtractor in digital world? Subtractor is the other basic function of arithmetic operation of information processing tasks of digital computers. Similar to the addition which we did in last classes, subtraction of two binary digits consists of four possible elements, which is if you subtract 0 from 0, then we will get the 0. 0 from 1, it will return 1, and borrow of 1. Okay, if you minus 0 from 1, then 0 from 1, if we minus, then we will get result 1 in result and 1 in borrow. In that case it is not called carry, it is called borrow. Okay, and if you minus 1 minus 0, no problem, then 1, and 1 minus 1, then 0. So this logic we have to implement it by our circuit. As like the half adder and full adder, the same logic here in half subtractor and full subtractor. So first we go for the half subtractor. See the truth table. See, when we subtract 0 from 0, it will result 0 and borrow is 0. Now if you subtract 0 from 1, then the result is 1 and borrow is also 1. Now if you subtract 1 0 from 1, then it will result if you subtract 0 from 1, it will result 1 and borrow is 0. Now if you subtract 1 from 1, then obviously the result will be 0 and borrow also will be the 0. So it is our truth table. Now by implementing this truth table, we can get the same d is equal to x bar y and x y bar, and b borrow is equal to x bar y. Now if you want to see how this x bar and y bar is come, then we have to make the what? Karnaugh map. So make a Karnaugh map with 2 input here. See how it come. How this truth table is going to be drawn? We get here x and here y. The relation we have to drawn. This is 0, this is 1, this is 0, this is 1. Now for this output d, see, for the place of 0 0 it is 0, for the place of 0 1, that means x is equal to 0, y is equal to 1, the output is 1, and for x is equal to 1 and y is equal to 0, it is again 1, and for the place x is equal to 1, y is equal to 1, it is 0. Am I right now? Now make a circle. We have to make a circle single because we cannot make a loop. So now get d is equal to what? D is equal to, from that end, for this loop we go for loop 1 and go for loop 2. That will be loop 1 L1 plus L2, and loop 1 is equal to here x bar y plus x y bar. See, it is written here x bar y and x y bar, and same thing like that we can get the relation of borrow with the input of xy. How? Draw here again Carnot map. Here x and y. See, for x0, y0, borrow is 0. So here 0, because this place is x0 and y0. And for x0, y1, there is a 1. So that place it will be 1, and rest of all place it will be 0. So your borrow will be, B will be what? X bar y. Am I right? So we have to implement this both circuit in a one form. So see this circuit, it is a truth table of XOR bar, x bar y plus xy bar. It is a logic equation of XOR bar. So we can get the D from direct XOR bar. So we give xy input to XOR gate. Now we get the borrow. The relation of borrow is x bar y. So we need a AND gate. See here, we use a inverter. That is why here we get x bar, because from that position the inverter get x. Now after this inverter we get x bar, and here we directly get y. So after this AND gate our result will be what? X bar y. Am I right? So it is a half subtractor, because both the equation is fulfilled by this circuit. So by using this circuit we will get the half subtraction. Take an example. Suppose this, we take this example. We have to subtract x is equal to 0 and y is equal to 1. Then what will happen? See, for a XOR gate, if the input is 0 and 1, then output will be 1. So D is equal to 1. And what happened here? This 1 is come here, and this 0 is inverted to 1 by this NOT gate. So the AND gate input is 1 1. So borrow also will be 1. See, for 0 1, output will be 1 and borrow will be 1. So fulfill this circuit. So we can say this is a half adder circuit, half subtractor circuit. Am I right now? Okay, now go for the full subtractor. As like the half subtractor, full subtractor also include the borrow. In we see that in previous case for full adder we calculate the carry for the next operation, because it process the 3-bit operation. So in case of that we have to calculate the borrow, and these x are used for the borrow, or you may call the previous input or previous output, previous state. So see, if the all input is 0 0 0, then the output is 0 and borrow is 0. If 0 0 1, then output is 1, borrow is 1, because if you minus 1 from 0, then the output will be 1 and borrow will be 1. Now for that case again same result, because this 1 have to minus with this 0. So same result. Now if we minus 0 1 1, then we get the output 0 and borrow is 1. Because first we minus 0 from 1, then the answer will be, if we minus 0 from 1, then the answer will be 1 in result and borrow 1. Borrow 1. Now again we have to minus this 1 with that, then we get borrow 1 and result 0. See here, result 0, borrow 1. In that way we get this complete truth table. Is it clear, Bhandari? Yeah. So for full subtractor we get this truth table. Now by implementing this truth table on a Carnot map, see how for the result of this output we get this Carnot map, and for that we get this S is equal to this relation, and for sum to solving that we get the relation this one. Okay, now from this equation we have to implement our logic circuit. How it being possible? See, by this way it will be possible. Just seeing this output from the Carnot map, because see, we have to multiply x bar, y bar, z. That means we have to introduce one AND gate whose input will be x bar, y bar and z, and again we need another AND gate whose input will be x bar, y, z bar. We need another AND gate which need x, y bar, z bar, and another AND gate we need x, y, z. See, this circuit we introduce the 4 AND gate and give a input same which form we get by the equation. See the input, first AND gate x bar, y bar, z. See here, the first gate x bar from here, y bar from here, and z from here. The second AND gate, see, x bar from here, y from here, and z bar from here. The third AND gate, x from here, y bar from here, and z bar from here. And the last one, x, y, z. It get complete x, y, z. See, here we implement x, y, z and x bar, y bar, z bar. Whatever AND gate need x bar, we just take a short this circuit from x bar. If it need x, then we short from the x. In that way we make the 4 AND gate circuit. Now this 4 AND gate circuit is relation with added each other. See, added the all AND gate, and we know this addition will be done by the OR gate. So that is why we use a OR gate, 4 input OR gate, and every output from the AND gate we add it. In that way we make our circuit, desired circuit, for getting the output. And same like a borrow, for getting the borrow we use this circuit. So by getting the relation of x, y, z, we have to implement the circuit. So in that way we have to build our digital circuit. Okay, now same thing like the last class we did, the using the half adder circuit, 2 half adder circuit, we made a full adder circuit. In that case also, using the 2 half subtractor circuit, we can make full subtractor circuit. See, it is a 1 half subtractor circuit, and it is another 1 half subtractor circuit. Sorry. Now see, the extra input z is fed to this gate, and the output of the 2 borrow is ORed by using a OR gate. In that process we can easily make the full subtractor using the half subtractor. Is it clear to all?